Now, vapor pressure has its own video because it's a little bit more difficult to understand vapor pressure, and we're going to do some calculations with it. So vapor pressure for liquids, if you think about vapor pressure, vapor is the gas part. So why are we talking about gases when we have liquids? And that's because if you have a liquid in a closed container, that airspace in the top is going to have some gas particles in it. Some of that liquid is going to turn into gas. Like if you have a container, a bottle of water, there's water particles, gas particles in the top part there. Okay, so vapor pressure is the pressure of the gas molecules above a liquid in a closed container. So I have this closed container. If you have a liquid, some of them are turning into gas. So they're kind of like going back and forth. Some turn into gas, some turn into liquid, and vice versa. Okay, so if something has a high vapor pressure, that would mean it has a lot of gas. So if you're looking at B versus C versus D, well, C and D are the same, I think. This has a much higher vapor pressure because a lot more of the particles are in the gaseous phase. Now, what would cause that? Well, that would be things that have low attractions or low intermolecular forces. They would more easily go into the gas phase. So if you're looking at B versus C, we would assume that C has weaker intermolecular forces because more of the particles are in the gas phase than for B. So really what's going on in these containers is that condensation and evaporation are happening both at the same time. It's just that this one is producing more gas, so this has a higher vapor pressure. Okay, so vapor pressure itself will increase with temperature. Of course, as you heat something up, we know gas particles move faster, more of them will turn into gas. So you'll have a higher vapor pressure as the temperature increases because you have more gas. So again, looking at a plot like this, right, you look at the height or at the peak, sorry, and where it is. Lower temperatures are going to have lower kinetic energy, higher temperatures have higher kinetic energy. And this is like the line of where things are going to turn from liquid to gas. So if you have a higher temperature, you'll notice there's more particles or the area under the curve that are going to be in the gaseous phase. So higher temperature, more gas. You won't have to explain this section. Okay. So this brings us to like boiling point and how that changes. So boiling points are the temperature at which the vapor pressure equals the atmospheric pressure, which might not be what you think of when you think of the boiling point. You're like, oh, the temperature when it turns into gas. Well, things turn into gas when their vapor pressure is the same as the atmospheric pressure. They're going to go into the gas phase. So that just so happens at 100 degrees Celsius for water. Okay. Now it does change when the pressure changes. So you know that water boils at 100 degrees Celsius at sea level or where we are-ish. And at higher altitudes, water boils at a lower temperature. And that's because the vapor pressure is going to change. The atmospheric pressure is going to change. So the boiling point is going to change. So we have what is called the normal boiling point, means the boiling point at 1 atmosphere. So water's normal boiling point is 100 degrees Celsius at 1 atmosphere. It's like 86 or something like that up in the mountains. Okay, so 100 degrees Celsius at 1 atmosphere is called the normal boiling point for water. So you'll see on this graph, I've got temperature, I have vapor pressure over here. You'll notice that water is at 100 degrees Celsius when I'm at 760 torr. But as we go to lower pressures, the actual boiling point will decrease. And that happens for most all substances. So your boiling point is going to depend on the atmospheric pressure. Okay. So I think that was all I was going to talk about that one. Yes. Okay. Because we're going to get into phase changes and how to determine what's going on with those.